Great. So, welcome to the third last session. And we have Thomas McGuire, who is going to be telling us everything about how to do QML effectively.
Thank you, Dan. Hello and welcome. As Dan said, I'm going to talk about efficient QML. And if you wonder what that title is all about, I stole it from Scott Myers. Scott Myers wrote some books called Efficient C++, and they are basically a collection of items on how to improve your C++. So I'm doing the same here. I've got a collection of items on how to improve your QML. I've roughly divided this presentation into 4 different topics. We start with tooling, because even if you're a superstar programmer, if you just got notepad.exe and a compiler, you will not be productive. You need tools to support you, like an IDE with syntax highlighting, auto-completion, code review systems, ECI, and so on and so on. So I'll have a very quick look at some QML-specific tooling. The next topic is understanding. Especially QML makes it deceptively easy to just go and code some application with actually not understanding what's going on behind the scenes. I think understanding the system is important, because only then you know the limitations of the system and you also know the capabilities of the system. So I picked out a few interesting things about the QML system that you should know about. Then we come to our main part, which is coding, where I will show some best practices for QML, how you should design your QML application to get the best out of QML. And lastly, if we still have time, that will be a question, I have 3 or 4 tips about performance in QML. So without further ado, I'd like to start with the first tip. And the first tip is know your profiling tools. Because surprisingly, I still know people who don't know the QML profiler. I had one person coming up to me, "Hey Thomas, my application is slow, what do I do?" "Have you tried the QML profiler yet?" "The QML what?" So if you haven't seen the QML profiler yet, you should have a look. Using the QML profiler could fill a complete talk, so I'll just tell you it exists. It supports remote profiling on embedded devices, and it basically shows you an overview of the high-level QML elements, events, like what objects are created, what bindings are executed, and so on. You always need to combine that with a normal profiler, like with a C++ profiler, because QML is not always the performance problem, and you have to figure out where the problem actually lies before. So you need a combination of profiling tools, and the QML profiler is one of those tools. In the enterprise version of the Qt Creator profiler, you have some additional rows that show you details about the rendering. Those details are not available in the normal version, but there is an environment variable, QSG render timing, which you can use to get the same numbers, although only in text form, so they don't line up nicely in a timeline UI like in the QML profiler. So use the QML profiler when you need to. Then there are a bunch of environment variables. They are documented actually, but most people still don't know about them, so I quickly will show you. They're called QSG visualize, and they show you certain properties of the system. In this case, the overdraw visualization, which shows you how many layers of items you have, so you can debug and disable items that you don't actually need, which is needed for limited GPUs. I can actually demonstrate that here. So, is this on? So my presentation program here is written in QML, so I actually can demonstrate that live with the presentation program. Let me just see. So this is the overdraw visualization in my presentation program, and you see we are not actually doing the best thing here. We actually have a slide outside of the screen which we forgot to hide. That's not good for performance, so it's a useful tool to track down performance problems. Go and read the documentation about all these environment variables, please. Should we continue the presentation like this? Probably not. I will restart. Okay. Then there is some tools I almost built into every application I write with QML that are not part of Qt itself, but which you can add with a few lines of code that are tremendously useful. The first one is to add a shortcut where you can reload your QML. Usually when you change your QML, you need to recompile your application or restart your application to load the new QML file. That's especially time consuming if you just want to change a few pixels, like check if the button alignment is nicer if you move it 1 pixel to the left. It means you need to restart your application, navigate to your page again, and then check the result. That is cumbersome, and what you can do is you can add a shortcut to do this automatically for you without restarting the application, and it is quite easy. Just subclass QtQuick add an event handler for keyboard events, and in there clear the source, clear the component cache, and simply reload the source. That helps to increase the productivity. I, of course, did that here for my slide viewer program as well, so let's try that out in a live demonstration. So I've got the presentation here in a QML source code. Please don't crash. So I'm going to reload now. And wait a second. Reload here. Takes a while. Or it crashed, I'm not sure. I think it might have crashed, actually. Oh no, I've got a syntax error. Why did no one tell me? I got a very simple syntax error somewhere. What did I do wrong? Damn, I don't know. Let's revert this. I should have made a backup copy. Anyway, so live demonstration didn't work, but trust me, it works and it saves you a lot of time. Sometimes it crashes, so this time it was my fault, I had a syntax error. Sometimes the thing actually crashes. That's because there's a bug in the QML engine. I reported it, but nothing happened so far. But it rarely crashes, still a big increase in productivity. The other shortcut you should add is to slow down and speed up animations. Because if you do animations, you want to check that they're running correctly, and if they run within 250 milliseconds, at least my eyes are not good enough to check the details and to see what exactly is going on. So at these shortcuts, you press a button, and the animations are slowed down by a factor of 10. Okay, next tip. You might know qmllint, or you might not. It's new in Qt 5.4. It is a very basic syntax checker for QML files. So it statically checks the syntax of a QML file and will complain if there are any errors. This qmllint tool is quite limited because it can't know about components because some of them are registered by C++. And it can't know about properties in JavaScript, doesn't know if they exist at static check time. But it is still useful because the tool exists, and what you can do is simply integrate that in your build system and you will catch some obvious errors, like merge errors with Git or errors like this. I have to admit, I prefer CMake to QMake. So my example here is CMake, how to add qmllint, which is part of Qt, so you don't need to install it separately. And so I added a custom target, make lint. When I run that, it goes over all my QML files and complains if there's a syntax error. So you should integrate that into your CI system and you have basic checks. Of course, due to the nature of QML, QML is a dynamic language. Lots of stuff is only evaluated at runtime. If you want to properly test your applications or make sure there are no errors, you should actually make sure all the QML files are loaded at runtime to check if there's any error. So you need actual either manual testing or automatic UI testing to test things properly. But this thing can catch some obvious errors. Okay, next tip, next tool, which is Gammaray. Gammaray was written by KDAB. You might have seen it already. It's on our booth. What I want to quickly show is the QtQuick view, since we're talking about QML and QtQuick here. And in the QtQuick view, you have access to the QML item tree. You have a nice visualization of your layouting and your margins and your anchors. So this can be useful also to introspect existing applications or to debug your current application. It shows you where the keyboard focus is, which item is visible, which item is not visible, so it can be helpful for debugging. It also has a scene graph view, so if you are developing your own custom QtQuick items based on the QtQuick scene graph, this view here helps you debugging that. So this is my name in triangles, which is what QtQuick uses for text rendering. Okay, then we have some tips. There are some environment variables in Qt that are useful, again, for tooling. The most important one for me is probably the first one, Q for force interpreter equals 1, because that disables the just-in-time compiler and instead falls back to the bytecode interpreter of the JavaScript engine. That is useful if you want to do debugging and to look at backtraces, because just-in-time compilers have the tendency to screw up backtraces, and lots of times the backtrace just stops in the JavaScript code and doesn't go any further. So by using that environment variable, you can get nicer backtraces. When you run your application from within Qt Creator, I think Qt Creator sets that environment variable automatically, or at least somehow it disables the just-in-time compiler. QML import trace, you might have seen that already. If you have trouble finding your QML files, especially if you use modules, you should use that environment variable for debugging. What I actually did, I went through the source code and grabbed the source code for getenv, which is the syscall to read environment variables. And with this, I found define bool config option. I also grabbed for that. And I found a whole lot of stuff that is useful. For example, there are some checks you can enable. Each check doesn't do much, but still you should have the checks enabled. They might catch an error. So in this case, if you have an obvious memory leak, that check, that environment variable will catch that memory leak. For QtQuick items at least. Unfortunately, you have to set the environment variables from the outside. You can't set it from the inside of your program because in Qt, the environment variables are read right at startup even before your main function starts, so you can't set the variables in the main function. You need to set it from the outside. Okay, now we go to the understanding section. I've shown you some tools, some basic tools everyone should have in their toolbox. Now I'm talking about some maybe lesser known corners about Qt and QML that you should understand. And the first tip is actually something everyone should do, but most people don't. Read the documentation. Not just the API documentation. Everyone knows the API documentation, right? When you use a rectangle of the first time, you should have a look at the API documentation for a rectangle. But I'm not talking about the API documentation here. What is maybe less known is that Qt actually has excellent overview documentation articles. So this is a screenshot from the documentation about the scene graph. You can even see someone that made a nice picture, probably spent like an hour or two making that diagram with some finicky diagram software. So someone took the trouble to write a nice article how the scene graph renderer works, and it actually gives a very good overview, and I think you should read that. So hidden in the Qt documentation, well, not maybe hidden, but in the Qt documentation, there are some excellent overview articles. Some of my favorite ones, first of all, go to the landing page of QML and of QtQuick. The landing page will show you some of them. And my favorite one is about the QML type system that introduces the types used in QML, like what a property var is, what the difference, what types from C++ are supported, and so on. Similarly, if every big application you integrate your QML with C++ somehow, and you need to know how the type conversions work, what types you can use in a Q_property macro, how these types get converted to C++ in the QML world, and what happens to a QVariant map when you export that, what will it be in JavaScript. All these things are something you should know, you should learn about. This page is quite good. Then the scene graph documentation I've just shown. So there's an excellent scene graph documentation and even a page about the scene graph renderer which shows you some details. There is a page about performance. Everyone should read that as well. Some bits of it are a bit outdated, so it still talks about optimized bindings, which no longer exist since Qt 5.2. But still, it's a very good page telling you a lot of good tips, much more stuff than I could fill with this presentation. So go have a look at that and get some performance tips from there. And of course, the QML profiler, which I only showed briefly, is actually extensively documented at the page here. Okay, now I want to talk about two topics which are documented, but most people don't know about it, so I thought it's important to talk about them. One is object ownership. Normally we have two worlds. We have the C++ world. In the C++ world, when you allocate something with new, you have to call delete to get rid of the object. Or you have to set, if it's a QObject, you have to set the parent, then your object gets deleted, then the parent gets deleted. Or you put your object on the stack, and the object gets deleted when the function leaves that stack frame. So we have the C++ world, where we all know how to manage our memory. Then we have the QML world, right? In the QML world, when you declare a rectangle, so you write rectangle curly braces, that rectangle gets destroyed when the QML object, when the QML component gets destroyed as well. When you create an object dynamically with Qt.createObject, it gets destroyed by the garbage collection. So taken separately, the QML world and the C++ world are well understood. The trouble begins when you mix both worlds. Say you have a C++ class that has a member variable mSongs, that is a bunch of song information, bunch of QObjects owned by the C++. You have a method that returns the first song to QML. You can use that in QML to assign that to some property. And here the trouble starts. Because in this case, QML actually takes ownership of your song and tries to delete it when the garbage collector runs. But your C++ code also tries to delete the song at some point, and you get a nice double deletion. So in this case here, both worlds conflict. So when you hand out QObjects from C++ to QML, you should be careful about that, because QML in some circumstances assumes ownership. Fortunately, this is documented. If you look at the object ownership enum, the documentation, the rules are a bit confusing when QML takes ownership and when not. The good thing about that is you can override the behavior. In this case, you hand out a QObject. You know the QML engine should not gain ownership. It should not delete the object. It should not garbage collect it. You can call set object ownership to override the default behavior. So go and read that documentation. If you ever had some unexpected crashes or objects getting deleted, this might be the reason. Then there is a nice or not so nice thing in QML. You know, in QObject has an object hierarchy. Each QObject has a parent, and a QObject can have multiple children, which is fine. The parent deletes their children. It's all good. Unfortunately, in the QML world, things are not that easy, because in the QML world, there's actually also a parent item. And the parent item defines the visual hierarchy. So if something is the parent item of another item, it will get drawn below the item. So it has effects on the Z order. And a child item of a parent item will have the coordinates relative to the parent item. That's the visual hierarchy. And ironically enough, the parent property in QML does not mean parent, but it means parent item. That is a nice confusing situation which I ran into one or twice, because most people assume there's just one property, but there are actually two, parent and parent item, and you need to be aware of that. For example, if you use a repeater, a repeater will set the parent item, but it will not set the parent. So parent and parent item will be different when your object was created by a repeater. And sometimes you manually change the parent. For example, when you we often have that when we have a pop-up or an overlay, we want to reparent that item so it gets to be shown on top of everything else. You need to be aware that just changing parent item won't change parent. So you've changed the visual hierarchy, but you haven't changed the object hierarchy. So that is something to keep in mind. Whenever you play around with parent or parent item, be sure to know the difference and that they're actually two different things. Okay, next tip. In some situations, the QML engine will invoke methods of your item. So if you have written a QtQuick item in C++, the QML engine will call methods in it. And to know which methods are called, it's important for debugging and for profiling. Because if you see a certain thing taking a lot of time in the QML profiler, you want to know what C++ code is behind that. So if you only look at loading a QML file, you have basically three methods getting called. So when the QML file is compiled, nothing much happens. But after that, when the objects are created, the QML engine will of course call the constructor of your item. Then it will call class begin on your item. Then it will do binding evaluation, and after the bindings have been evaluated, it will call all the property setters on your item. And afterwards, it will call component complete. And this component complete is actually something that takes a lot of time for images and for text elements, which you might see in the profiler. So this here is the creation phase, followed by the completion phase. You see the completion phase takes a long time. For example, an image loads the actual image from disk in the completion phase. So it's important to know that this method exists and it gets called and what it does. That's during creation. During rendering, we have basically two methods getting called. One is update polish, which the QML engine called, or the QtQuick renderer calls on your item, so the item can present itself and make itself ready for presentation. Then it calls update paint node to get the actual scene graph items. And still it's important to know this, because if you have ever used a canvas element, or you have misused a canvas element, then you might have seen that the update polish takes a long time, because the canvas item does the actual rendering in update polish, just before it is shown. And the actual rendering, no code gets called. So once update paint node was called, the scene graph has its item and it has its scene graph nodes and it leaves your item alone. Okay, so those were the topics I want to talk about to understand how the QML engine works and how QtQuick works. Now I want to proceed to best practices when actually writing programs. And the first one I want to talk about is the layering. In every complex applications you have layers. You have a C++ layer and you have a QML layer. Mostly the QML layer does just the logic, and the QML layer does the UI, and the C++ layer does the business logic. So, but what you also can do, it's written on this documentation page, you can from C++ access items in your QML and manipulate them. So, for example, let's take the hypothetical media player again. We have some code in C++. They use find children to find a QML element by object name. And then, for example, you can change the text of a text element in QML from C++. Or you can find a button in QML and connect to the button signal. Or you can even call functions in QML. Don't do anything of this. Forget that I showed you this page. Never read that documentation page. It only lists evil stuff. I would advise to never, from C++, never reach into QML. It's a layering violation. Okay, who did that? Well, can you turn it down again, please? Okay, I've got light. So the reason you shouldn't be doing this is because if each layer interacts with the other layer, if the lower layer reaches into the upper layer, you can't do certain things. For example, assume in the UI we want to change the buttons. We don't want to have a next and a previous button, but instead we want to have a swipe to change the song. So someone changes the QML to have a swipe to change the song, and now suddenly the next button doesn't even exist anymore, and the C++ code will break. So this has the big downside: when you change your QML code, you break your C++. Also assume you have different QML files for Android and iOS. Doesn't work as easily because you need to have these object names and these function names in both QML files. You're not free to write your QML files as you want them to be. What you should instead do is from QML access C++. The C++ layer should not know anything about the QML layer. It should not make any assumptions about the QML layer. In this case, in the QML, we can access properties from our C++ objects. Or we can call functions from our C++ object and bind to properties. That's the proper way. The QML accesses stuff from C++, but not the other way around. I think I mentioned these. Right, stuff doesn't break when you do refactoring in the QML layer. You're free to change the QML layer as you want, and the code gets much easier to understand because you know there's only one direction of data exchange. Tip number 11 is about being declarative, and that is something you can't do from one day to the other. That's something you get used to. If you're like me, we were probably all from a C++ background originally, and what we have is imperative code. We have lots of lines of code that tell the program what to do. And that's called the imperative approach. But QML allows us to write a declarative approach, which is completely different. I think I want to demonstrate that on an example. This would be the imperative approach. I change properties and I invoke methods. I tell the program what it should do by having statements that are all executed. That's the imperative way of doing programming. What you can do instead, now just look at the QML code for a second. What you can do instead is just, instead of changing the icon manually by an assignment, you can use a property binding. And the property binding will change automatically. You just declare what happens. Sometimes you still need assignments like here, but the QML layer in general should avoid assignments and other imperative code. It also means your C++ code will get imperative. What it means is basically you get your imperative code and you move it into C++. And the QML layer should be as declarative as possible. Makes the QML layer much easier to understand and much more pleasant to write. Again, you still need to have assignments and function call somewhere that's in the C++. This is not limited to binding. So one classical example is, do not just take your C++ object and add some QInvocable or slots to it. Instead, add properties to your object to export to QML. Because if you have properties, that enables you to write declarative code by using those properties in bindings. So instead of signal slots and QInvocable methods, have as many properties as possible. It's not limited to that. You can also design declarative API for complete components. For example, the repeater is a good example. Instead of having a for loop where you create n items, you use a repeater, which you simply tell, I want n items of this type, please do the work for me. So in this case, the repeater has imperative code internally, but the API of the repeater is nice and declarative. Same with the behavior. You don't start an animation manually, you just tell the behavior element when you want the animation to be started. So think about that when designing your C++ classes that you expose to QML to make their API declarative. And especially, you might know the word code smell when you look at a code and think, oh, this might not be the best. One code smell is definitely assignments outside of signal handlers. So in signal handlers in QML, sure, you need to react to something that can only be imperative. But outside of signal handlers, assignments are a sign that you might be able to do it in a more declarative manner. Like the assignment to the icon property here, which we were able to replace by a binding. And then I think I invented that word. A code stink is a stronger smell. If you have a on property changed signal handler, so for example on color changed signal handler, that almost always can be refactored into a binding directly. Because you react to a property being changed, you might as well let the QML engine do that automatically. Okay, the next one is controversial. The next one is what I think is correct, but which might not be the opinion of everyone. I think you should avoid JavaScript code as much as possible. I think when you have lots of JavaScript code, that is a code smell, and you should think about moving that code to C++. And there are two main reasons why I think that. One reason is performance. JavaScript code is, I don't know, 10 or 50 times, something like that, slower than the equivalent C++ code. So it will gain you a big performance advantage. Second one is maintainability. If you have your code in C++, the C++ compiler will check the code for you at compile time. If you have the code in QML, in JavaScript, that code will only be checked for correctness when it's actually run. So the only way to check that all JavaScript code is correct is to actually execute that JavaScript code. So you need to basically go over all of your I, try all the features out, let all the JavaScript code run, and only then you can be sure that the code is correct. So I'm a big fan of avoiding JavaScript code and doing stuff in QML when it makes sense, in C++ when it makes sense. There is, of course, a limit, like some JavaScript cannot be avoided. Typical case is a binding. A binding is JavaScript code, and that's, of course, fine, because a binding is just a tiny snippet of JavaScript code. But if you have a JavaScript function of 30 lines somewhere in your QML file, you should or could think about moving that to C++. So JavaScript code in bindings is unavoidable, and it's actually a good thing. JavaScript code in on-clicked handlers, for example, is also fine. Mostly they just trigger some C++ code, maybe. So that's my opinion. Others disagree. And in the Qt examples, in the QtQuick examples that ship with Qt, you'll find actually complete games written exclusively in JavaScript, like the same game. Might be nice for a game, but might be not as nice for an application you have to maintain for 5 years. And tip number 11, that was the previous one. If you are as declarative as possible, it means you move the imperative logic to C++ anyway, so tip number 11, be declarative, and tip number 12, avoid JavaScript code, kind of play together. Okay, this is an interesting topic. That's also something that might be controversial. Avoid storing non-UI state in QML. With state, I mean anything like this, having lots of properties, for example, that save some state. In this case, the state is the volume, which we remember in QML here. So we have a music player. That music player, it doesn't actually know, the C++ class doesn't actually know the volume itself. It has some backend which might have the volume, but the class itself doesn't know the volume, and the volume is stored in the QML file here. And when we want to change the volume, we basically have to change it in the QML file and then tell the C++ code about the new value, maybe. A better approach might be to move the state into a member variable in C++. So now the volume is in C++ as a member variable, and the QML file simply binds to it or calls methods that change that state somehow. Now we move the state to C++. One thing that will automatically happen, you might have noticed, when I change the state in QML, I need to have some business logic that has some decisions about what the new value should be. And when you move the value itself into C++, it automatically the business logic moves to C++ as well, which is also an advantage. It's also much easier. In this case, the volume, let's say someone changes a hardware button and you want to change the volume, you can react to that directly in your C++. So you don't need to like forward the signal from the hardware to your QML layer and then modify the volume there. So it's also easier to react to changes. One effect that has, or one reason why I'm saying that, remember my reloading tip? When you press F5 and the QML file gets reloaded? If you store state in QML, all that state gets lost because the QML files get completely reloaded, so any property you declare in QML is gone after reloading. And if you instead store the state in C++, reloading will reload the UI layer, the QML file only, and the state will still be in C++ because that hasn't changed. Actually, a colleague of mine gave me the tip for C++ as well. He said, Thomas, in C++ you should also avoid state whenever possible. And I noticed that basically means have as few member variables in C++ as possible. I noticed some of my code had redundant member variables that could basically be calculated from other member variables. When I change one member variable, so let's say I have one member variable which kind of depends on two other member variables. When I change one of them, I always need to update the other one. And that's very error prone because it's easy to forget. And it's much better to simply get rid of that member variable and maybe calculate the value on the fly with a helper function. Kind of goes into the functional programming here, but I always will remember that tip from my colleague because now I always, when I add a member variable, I think, do I really need that member variable? Or wait a second, is that member variable not already stored somewhere else and I can simply access that from there instead of duplicating it here? So thinking about reducing state helps because it makes your application simpler in general. Okay. Tip number 14 is about writing QML components and making them reusable. Again, I will be using the music player as an example. Let's assume in your music player you have a list of songs, right? Simply a list view with all the songs you support for the user to choose one. One way to implement this would be this. You have your list view, you put in the model, your playlist from C++, and as a delegate, you use this QML file. It's nice, it all works, but this QML file is completely not reusable for multiple reasons. If you look in line number 3, the width is defined as the width of the parent, which already means this cannot be reused properly because you can't put it into an item where you say it should only occupy half the width. You can't say anchor to the left and use like 50% of my space. Doesn't work because we have hard-coded the width. We have made assumptions on how our component is used. So line 3 makes the item less reusable. Line 4, obviously as well, we use an attached property from list view, which means now we can't refactor our playlist to a grid view because it can only be used in a list view now. Then we have line number 7, which is really, really, really evil. Unfortunately, it is possible in QML. It is JavaScript legacy that this is possible, and it is very bad. What we do here, we access an ID, the show album art ID, and that ID is actually defined in a parent context in a different file. This is bad because if you refactor this file, suddenly this file will break. It is also bad because if you read this file, you don't see where the ID is coming from. It's something that you should avoid at all costs. Never, ever in your program. So some of my tips are opinionated, right? Like not using JavaScript or avoiding JavaScript and so on. This tip is not opinionated. This is indeed something you shouldn't do. Don't access IDs from other files. It's just confusing. It makes refactoring difficult, makes the code hard to maintain. And it's the reason that you can't do that is just an accident. It's JavaScript legacy. There's talk about adding a strict mode to QML that limits certain things like accessing undefined properties and so on. And the strict mode would also disallow that. But so far, the strict mode hasn't happened. So yes, this makes it only possible to use our song info in context where they actually have a show album art ID in the parent context somewhere. Then we have two more. That is accessing the model. I access properties from the model, which itself is fine. But imagine I want to display my song info outside of a list. For example, just to display the current song, somewhere where there is no list. So I have no model, and this makes the item less reusable. What you should do instead is make the component reusable. My song info now has a bunch of properties, and we set the properties from the outside. You'll immediately see it's more code. It's more code, but it's also cleaner because this song info is now reusable and it doesn't make assumptions about the context it's being used in. Sometimes it makes sense to write code like this if it's really like one tiny component being used just in one place. Sometimes it's okay because it saves a lot of typing, but in most cases I prefer doing the real work of making the API proper without and proper reusable, like this here. So I think that already mentioned. Right, so we said avoid setting the width in the item, because then you can't use anchors. Same, don't set the X position, don't set the Y position, don't set the height, and don't use anchors in your component. Let the user of your component decide what the width, height, and the anchors should be. Okay, actually we have plenty of time. That's great, because then we have enough time to talk about some performance issues. And the first tip is a little bit obvious, but the biggest performance problem in my experience in QML is when you start your application, it takes a long time to load, or when you switch to a page, it takes a long time to load. And the reason is simply because the QML engine is not so good at creating lots of items. So if you have a QML file which creates lots of items and even loads sub-QML file with even more items, the QML engine is not that fast in creating those items, and especially on embedded, they often create a performance problem. And the way to avoid that is A, make all your items less complex, or B, don't load all these items. Put all these items, for example, behind a loader. Or make the item loading non-blocking. For example, by setting the, is it here? No, oh, that's the next tip, sorry. So reduce the complexity, especially at startup, of the stuff that get loaded. Try to load fewer things. This is, by the way, one of the major reasons the Qt company is now switching from QtQuick controls to QtQuick controls 2, because QtQuick controls 1, the items were simply super complex. Even for a button, they basically had 10 items in QML that get loaded, and that overhead adds up over the time. And the new button in QtQuick controls 2 is just one C++ part. Again, they actually moved stuff from QML and JavaScript to C++ for performance reasons. So the new button is a big C++ code and a tiny UI layer in QML on top. So QtQuick controls 2 will be more performant because they reduce the complexity. And one trick they used is moving stuff to C++. Of course, it's a trade-off, unfortunately. If you put everything behind a loader, at some point it needs to get loaded. For example, when you press a button and a different page is shown, that page needs to be loaded. So loader is a trade-off between performance on demand and performance at startup. You need to carefully balance the two. Also, loader has another trade-off. When you unload or when you load something and that something has bindings, these bindings are even evaluated when the item is not visible. So you load a settings.qml file on demand because you need it, then you close the settings, but the settings are still loaded, and the bindings will continue to be evaluated even if the settings are no longer visible, and that can cause performance problems if there's a binding that is frequently updated or expensive to update, or even if there are lots of bindings. And so what can be beneficial after you loaded something on demand by a loader to also unload the item again when you don't need it anymore. You can do that by setting the active property to false. Again, it's a trade-off. You need to look at each situation and decide what you need to do. So unloading an item can be useful to prevent the bindings from continuing to run. Okay, tip number 16, good old tip. It was still relevant in the QtWidget world, and it's still relevant in the QtQuick world. Don't do anything that might block the main loop, or the main loop in the event loop in the main thread. Because the QML engine, the binding evaluations in there, and almost everything happens in the main thread. If the main thread is blocked for a long time, that means if you do an operation that runs for a long time in the main thread, your animations will stop, your application will stop to react, and that's not good. QtQuick has so-called animator classes that you can use to run animations exclusively in the render thread. These animations will even continue to run when the main thread is blocked. But it won't gain you anything because it's not enough to let the animations running because you still need to react to input. So the main thread should never be blocked because it's also responsible for input handling and for other things. There are two cases basically where you block the main event loop. One is the event loop is blocked by QML and the built-in elements, and the other one is the event loop is actually blocked by the code you yourself wrote in C++. So for example, when you load a complex QML file, which you didn't put behind a loader, then it's the QML engine blocking the main loop for the time of the loading. The image element will block the main loop while it loads an image. So if you load a big image, maybe on an embedded board with slow I/O, that might take some time. With loader and with image, there are properties called async, which you can set to true, and those elements will not block the main loop anymore, but they will distribute their work over multiple event loop iterations. So an image will actually use a thread to load it in the background, and the loader will create like only a handful of items each event loop run. So some of the built-in elements have techniques to load stuff on demand. Text layout is also something that's very expensive, and in our slide here we hacked in a trick that the layouting of the text element is only done when it's needed and not at startup. So basically a trick similar to loader and image, because when we loaded 1,000 slides, it was slow in creating all these text elements, and we deferred that. So that's the built-in elements in QML. QML itself can be slow in loading stuff, but of course also your C++ code. You write C++ code, of course that's going to be called at some point, like when a property is accessed in your QObject, or when a method is called, or when you have a QAbstract list model that QML accesses and it reads data from it, called the data method. When code is rendered, in the end, that is all C++ methods somewhere that is C++ code you wrote. Of course, you should be careful in that too. And this is again where you would need a C++ profiler, not a QML profiler, to find out that your C++ code is at fault. But something to keep in mind all the time. Also, you might have network events or timer events you react to in C++, same story. We actually had one customer of us who had the requirement that the main loop needed to react within 200 milliseconds to input events. So in that project, we needed to be especially careful not to do any of these in the main thread. Okay, now this tip is especially for embedded devices. Embedded devices have a very weak graphical processing unit, very weak graphics card, unfortunately especially the IMX6, that are not able to draw as many pixels as you would want to draw. And because they are so limited, you should avoid or you should minimize the amount of pixels you draw on these embedded devices. Remember the scene graph overlay I've shown you, the visualization with the green and red rectangles that were displayed in 3D. That was a view to detect when you draw more pixels than you really need. And one example where you draw too many pixels would be this. Let's say you have a main.qml and you have a rectangle for the background. So you have one big rectangle filling the complete screen for the background. Then you have a toolbar. That toolbar again is a rectangle with a color, and within the toolbar you have multiple buttons, and again the buttons have a fill color. What you actually end up is with 3 layers of items. You have your background rectangle, then your toolbar, and then you have the tool buttons on top of them. And it's all rectangles in the same color. It's kind of a waste because you draw many pixels over each other, which in this case wouldn't be needed. So in this case, actually don't use rectangles. Set the background color once in the view, then it will use GL clear to optimize, which is a OpenGL command that is very often optimized the driver to simply clear the color and fill the background color with a certain color. And those other items then don't need a rectangle at all anymore. And you avoid the overdraw. You avoid drawing lots of rectangles on top of each other. Wait, you're making a photo? No? Okay. Again, the embedded device like IMX6, I think I had a look at the IMX6 Solo recently. They're surprisingly bad at that. They can basically only draw 1 or 2 full screen rectangles at 60 frames per second and not many more. So in this case, we really needed to watch out. Another thing to watch out for is items that are no longer visible. For example, a button that has moved outside of the screen, or a layer that is hidden behind another layer, which you know in your code. Set visible to false, because otherwise it will still be sent to the GPU. The QtQuick renderer, it has no viewport clipping, it has no occlusion culling, so it always sends everything it knows about to the renderer, except if you set visible to false, then you can avoid drawing them. If you have rectangles in your code, be suspicious. Think about, do I really need that rectangle, or can't I simply use an image here? Okay, and I'm not a salesperson from the Qt company, I promise you. Still, I recommend you to use the QtQuick compiler from Qt Enterprise if you have an enterprise license anyway. So if you have a Qt Enterprise license anyway, it ships with the so-called QtQuick compiler, and you should simply enable that. Okay, because the QtQuick compiler will pre-compile your JavaScript code, which means A, the compilation phase in your project startup will be faster, and B, the bindings will be evaluated faster, because the QtQuick compiler will actually compile to C++ code, which GCC will optimize, so bindings run a little bit quicker. When I measured that in a toy benchmark, it was, I think, 10% the bindings run faster. So if you have that thing anyway, go and enable it. That brings me to the end of my talk. So we had 19 tips, which I hope were useful in some situations for you. And thanks a lot for attending. Any questions you can ask now.
Please raise your hand for any questions, and I'll bring this thing to you. At least I'll try.
Regarding the second tip, with the reloading of the QML files, am I right that this only works if you have the QML files stored on the file system and not in your resources?
Right. If you have it in a resource, you can easily build a workaround that you reload the file from disk instead of the resource when you do the reloading. So that's what we actually did in some projects. You can even be more advanced and reload the files from the network if you're running on an embedded device, so you can make it more complex if you want to work for your situation.
We are running a bit short, so one more question. Lucky man.
Could you explain, please, what the difference or what this active property really does? Because we have run into some similar issues, and we were trying to set visible to false to stop it from consuming non-visible items too much performance. But we also see that bindings get still re-evaluated. So is active then the solution, or should we set active to false and visible to false to get completely out of the problem with non-visible items?
Yeah, so visible is a property on every item. Every item has the visible property, and when you set that to false, it will simply not be sent to the renderer. That's what visible does. Then the active property, only the loader has the active property. And when you set active to false, the loader will unload the item again. and will completely delete the item it loaded previously, which means the bindings won't run anymore. But it also means when you want the item again, it needs to be reloaded, which again is a performance cost. So you need, in your situation, to think, is it more important that I disable my bindings, or is it more important that when I access the item for the second time, that I don't need to reload it? So it's a case-by-case thing which you need to check.
Right. Thank you very much.
Okay.
Give him a hand, please.